Another very important concept that helps us in measuring the size of the deadweight loss or the size of the consumer surplus is called the price elasticity of demand when we're talking about the demand curve. We also have something called the price elasticity of supply when we are talking about the supply curve. Now, this elasticity really is about the responsiveness. Think about an elastic band. A demand curve is said to be highly elastic when there is a big response in terms of quantity change when price changes, because that's what the demand curve really measures, the relationship between price and the quantity that is being demanded. So the responsiveness is really about changes. If this was your initial price and that price dropped to some other price, say from P0 to P1, the price elasticity of demand will help us know by how much would the quantity concerned change. So what is the change there from the change there? So that's the change, that's the change. For a very inelastic demand curve, we would have a small change in quantity when price changes, because we've got an inelastic demand curve. Inelastic, it's not elastic. It does not stretch or it doesn't respond. This concept of elasticity is closely associated with the slope, as you should have imagined already. So, for instance, you know that the slope of the demand curve equals to changes in y, or of any curve for that matter, changes in y over changes in x. And really we are talking about a similar thing here, changes in price over changes in quantity that's being demanded. Changes in quantity that's being demanded. So, let me have a very steep, because I want to show you this relationship between elasticity and the slope. So let's say we've got a very steep slope of the demand curve, and you've got a change from P1 to a change to, change from P0 to a change to P1. What is the accompanied change in terms of quantity demanded? In this case, a big change in price leads to a smaller change in quantity demanded. But imagine if you had a different type of a demand curve that had a bigger or a flat slope. In this case, the change in price, the same similar change in price, maybe I should make it bigger, same change in price, would lead to a much, much bigger change in quantity. So a change in price here leads to a much, much bigger change in quantity that's being demanded. So we call this demand curve inelastic. It's not responding. Okay? Quantity changes do not respond to price changes. Whilst we call this an elastic demand curve. This would be an inelastic demand curve. And you can see that the slope of the demand curves show us what the elasticities associated with these demand curves are. But I want to caution you that elasticity is not the same thing as the slope. Elasticity is not the same thing as the slope. For instance, the slope along this linear demand curve is the same, doesn't change. If the slope is, say, 0.5 here, it will always be 0.5. If the slope is 2 here, along this slope, the slope is the same there, is the same there, is the same there. Even here, it's the same there. So the slope does not change along the demand curve. However, the price elasticity of demand changes along a linear demand curve. The price elasticity of demand changes along a linear demand curve. So you could have your demand curve there, and then you could have those associated price changes being related to changes in quantity. But the price elasticity of demand here is much bigger. It is higher here and it is lower there. What could be the reason for that? The reason for that is because we are measuring the price elasticity of demand in terms of percentage changes. So price elasticity of demand equals to a percentage change in quantity over a percentage change in price. And this is the reason why the price elasticity of demand changes along the demand curve. Another thing that you should note is that whilst the slope was a change in y over a change in x, you know that was the slope. Price elasticity of demand is the percentage change in quantity over the percentage change in price, whilst the slope is the change in price over the change in x, in the x variable. That is also very important. Do not mix them up. So we've got a percentage change in the x variable over a percentage change in the y variable when we are measuring the price elasticity of demand. I've already indicated to you that when we're dealing with the price elasticity of demand, we should also know that whilst here it is higher, there it would be lower. So it changes along the demand curve. And the reason really for that is because elasticity of demand, price elasticity of demand is measured in percentage terms. To illustrate and show you how that works, say for instance you had a change somewhere there, or say this was only one of units of this product that was demanded, and then you had a price change that led to your quantity demanded changing to 2. And then you had another price change that led to your quantity changing to 3. Let me just write them properly. So you've got quantity changing from 1 to 2. Because of that change there, you had your quantity changing from 2 to 3 because of that change there. And then you had to measure these quantity changes to measure your price elasticity of demand in percentage terms. So in percentage terms, a change from 1 to 2, you are adding an additional unit starting from 1. What would that percentage change be? That would be 100% percentage change. You've doubled the amount of units. You add another unit, you get 3 moving from 2. But in terms of percentage changes, what is that change from 2 to 3? It is only 50%. So changing from 1 to 2 is 100%, doubling up, but changing from 2 to 3 is only 50% because 1 is only half of 2. So changing by adding 1, you get to 3, but it's really increasing by 50% the units. So you can see that starting from 0, your percentage changes are decreasing as you get further and further. Your percentage changes are decreasing. Moving from 3 to 4, is less than 50%. You can work it out. But the point is that because we are measuring price elasticity of demand in terms of percentage changes of the quantity demanded, and then along this portion we've got 100% change, along that portion we've got a 50% change. Here we've got a percentage change that was less than 50%, and that contributes to our enumerator. The numerator. So the numerator is bigger, is getting smaller, and it's getting smaller. So this numerator is getting smaller and smaller and smaller. So what is happening to the price elasticity of demand? It's getting smaller as we move from this side to that portion of the demand curve. So we may find that we've got a big price elasticity of demand somewhere there, and then here we've got a small price elasticity of demand. A high price elasticity of demand is elastic. The responsiveness is high. Here it is small, so this portion of the demand curve is inelastic because this EP is small, inelastic. Right? So now you understand why moving from the high portion of the demand curve to the low portion of the demand curve, the price elasticity changes. And how does it change? It moves from being very big to being very small. It moves from being very elastic into being very inelastic. And that's because of the associated percentage changes. Right? And the same applies to the price changes. Now let's work out an example of how we would measure. And by the way, when we work out price elasticity of demand, we always measure it in absolute terms. So it is never a negative, it's always a positive. Okay, that's important to remember. So as an example, say you were asked to measure the price elasticity of demand along this demand curve when the changes are such that you had quantity changes from 6 units to say 2 units. So, and you would always be told where your starting point is. So you're starting from, this would be your point A, this would be your point B. And that was your associated change in quantity that is being demanded. And in terms of price, if you moved, say, from 6 rands to 8 rands, or from $6 to $8, and you were asked, measure the price elasticity of demand on this portion of the demand curve, starting from point A to point B. All right, it's very simple. You just apply the equation that you have been given, right? How do you apply your equation? All you do is first you measure the quantity changes, and then you measure the percentage price changes. So, you know, Q2 minus Q1 divided by Q1 in percentage terms times 100. This is in percentage. And what would that be? You're moving from 6 to 2, from A to B. Remember that, you're moving from A to B. So what would be your percentage change in quantity? So it would be 6 minus 2, sorry, it would be 2, because we are moving from 6. So this is our initial point, so it would be 2, because this is Q1, this is Q2. So what is Q2? Q2 is 2 minus 6 divided by Q1, which is that, which is 6 times 100. And what is that? Okay, it's minus 4, right, over 6 times 100. And really, what is that? That is 67%. You can just take your calculators. That is a 67% change. So now we know that the percentage change in quantity equals to 67%. Okay, it was a negative, but because we measure price elasticity of demand in absolute value terms, it's always a positive. Whatever negative number you get, you turn it into a positive, 67%. And then for this price change, percentage price change, what do we have? We have a change from 8, right? 8 minus 6 divided by 6. And you'll see that this is P2 minus P1 divided by P1. Right? And what is that? Times, don't forget to times by 100 because you're working with percentage changes. That would be 2 over 6, which would be 1 over 3, which would really be around about 33%. Right? 33%. So now you know that your percentage change in price equals to 33%. Moving from point A to point B of your demand curve. So again, this is your demand curve, and you moved from point A to point B. Point A was there, point B was there. What did we have at point A? We had quantity that was 6. At B, we had quantity that was 2. At point A, we had a price that was 6. At point B, we had a price that was 8. And we worked out that this is 67% and that is 33%. So 67 divided by 33. 67% divided by 33% is just above 2. So it would be 2.03. You can work it out. That's really how you work out price elasticity of demand. And you'd be given these values, and you'd also be told that you are measuring this price elasticity of demand from point A to point B. And that is how you would measure it. Now, the price elasticity of demand, like I've said to you, changes along the demand curve. It changes along the demand curve. Now, say for instance, you've got a demand curve where the slope was 1, meaning that a change here was accompanied by the same change there. If this was 20, this would be 20. If this was 10, this would be 10. So this is, it's a demand curve where the slope is 1. So meaning that this area there equals to that area there. For this particular type of a demand curve, whose slope is 1, at that middle point there, the price elasticity of demand equals to 1. The price elasticity of demand at that point there equals to 1. Whilst on this side of the demand curve, the price elasticity of demand is greater than 1. Right? Whilst on this portion of the demand curve, the price elasticity of demand is smaller than 1. And for a price elasticity of demand that is less than 1, we call that an inelastic portion of the demand curve, or inelastic demand curve. So on this side, the demand curve is elastic, meaning the EP value is greater than 1. So for the previous calculation that we just did, where we found that the EP was equals to 2.03, for that demand, or that portion of the demand curve, that portion was elastic because it was greater than